We are Group 3 from Concord High School's Tech Department in Wilmington, Delaware. Our design teacher, Dr. Estock, enjoys swimming at the YMCA and will often go swim a 2K. However, it becomes difficult to count 80 laps in your head while also working out. We decided to design a system that would make it easier for Dr. Estock to count his laps as he was swimming. We interviewed Dr. Estock as he laid out some aspects of the design that were very important to him. We wanted the device to be portable and fit in his gym bag, and it must be waterproof. We also wanted the device to be able to display some useful stats at the end of the swim in addition to the laps, such as total time, average lap time, and each 500-meter split. Our first design consisted of an above-water control box with a button that would hang into the pool. While this would give much more functionality, it would be way too large and would not fit in a gym bag. We decided to do some benchmarking to get an inspiration on a possible design. This led us to a very compact design that would display all the stats we wanted and would roughly be the size of a large cell phone. The bulk of the design work in the beginning went to the development of the circuitry and coding. This part of the process was the most troublesome and we ran into many issues. However, we did get it working in the end. The final design will use an LCD screen to display the stats after the swim and two LED matrices to display the lap number. After the swim is over, the device will display the total lap time, lap number, average lap time, and each 500-meter split up to 2,000 meters. The entire design will be placed in a waterproof cell phone bag and stuck to the side of the pool just under the water line. The case for the swim lap counter went through 3 main redesigns while figuring out how everything was going to fit together. In the first design, the component section was sandwiched between the top and the bottom portions, and the case would have 3 different layers. In the second design, the component section was altered to slide inside of the back like a box, and the top would sit on top as the lid to the box. Our final design is the furthest from the original, with the component section having the walls built in and the bottom sliding into place before the lid is placed on top.
So here's our final design for our component section. Right here is where we're going to house our 2 8x8 LED matrices. Here is where we will fit our LCD screen with this little hole to accommodate the back of it. And here is where we will put our 7-digit display timer in this little slot right here. We have these holes right here to these divots to house the backing and the wire so it all sits flush. And we also have measured the extrudes of each one of these so they all sit at the same level. As you can see, this looks a lot different than our older designs. We have these whole sides here, which is where we will accommodate our back and our top with pins to allow both of them to attach to each other. And we also have added these holes on the side and in the middle to accommodate wires so we can feed the wires through and house the Arduino and such in the back here. Here's the top to our design. All of these holes you see have been carefully measured to sit flush and center within our design. These 2 circles up at the top here will hold our 2 buttons, one to count which lap he's on and one to start and stop the timer. This smaller hole and divot will house our 7-digit display that will be our ongoing timer. These other 2 holes here will hold our LCD screen and our 8x8 LED matrix. Here is the back of our design that will attach to our component sections via these little pins here. This big hole on the side right here is for our switch that will turn it on and off the design. And this hole or divot in the back will house a magnet that will attach to one of our other parts I will show you in a minute, so it will be able to stick to the side of the pool wall underwater while being inside of a waterproof bag. Here's our magnet to suction cup adapter. This offset will hold our magnet that will attach to the back of our design. This hole in the bottom has been carefully threaded to be able to accommodate our magnet that will stick to the side of the pool wall. Here's how our parts will fit together. First, our magnet to suction cup adapter will screw into the magnet. Then, the back of our design will slide into the holes carefully placed on our component section. After that, the top will slide into the holes that we have designed on the top of our component section to all sit flush with one another.
Once we finalized the case design, we started to create test pieces to ensure that everything would fit together. We first fabricated the test pieces out of Luan using the laser printer. Then we started 3D printing specific test pieces that were designed to print quickly and use minimal filament. Once we were certain the components would sit in their designated spots properly, we printed one final test of the entire case to make sure the different segments would fit together properly and to work out the tolerances. Then we were able to print out the final case. With the case fully fabricated, we were able to take the final steps in constructing the entire swim lap counter by soldering the components to the circuit board and securing them in place. We would like to thank Dr. Estock for this opportunity, and while the system still has a few bugs to be worked out, we learned a lot from this project and look forward to refining it in the coming weeks.